Messengers from the stars. In the infinite darkness between the stars, something moves. Imagine a traveler, silent, cold, ancient beyond imagination. It was born in a place we've never seen, under a sun we do not know. For millions of years it drifted, crossing the void between worlds, untouched by any hand or light, until by a cosmic accident it arrived here, in our cosmic backyard. This is not the plot of a science fiction novel. This is the story of interstellar objects, real visitors from other star systems. For centuries, humanity stared at the night sky and wondered, do other solar systems form worlds like ours? Do they produce icy comets, rocky asteroids, even the building blocks of life? And if they do, could pieces of those worlds ever come to us? For most of human history, the answer was speculation. But in the last decade, we have seen them with our own eyes. Not in telescopes aimed at distant galaxies, but in our own solar system, moving too fast, following paths that reveal they are not bound to our sun. And what we found was stranger than anyone expected. Some were familiar icy bodies, alien comets shedding gas and dust. Others defied explanation, sparking debates about physics, planetary science, and even the possibility of extraterrestrial technology. In this deep dive, we will explore what interstellar objects are, how they form, how they travel across the galaxy, how we detect them, and why they might be among the most important discoveries in modern astronomy. We will meet the two most famous visitors, ʻOumuamua and Borisov, and the scientists racing to understand them. We will explore the radical theories, the controversies, and the future missions that may, for the first time, allow us to touch something made in another star system. The journey begins now. In astronomy, definitions matter. A comet is not an asteroid, and an asteroid is not a planet. But interstellar object is a category of its own, and it's defined by its orbit. Our solar system's residents, from Mercury to Pluto, from tiny rocks to giant planets, are bound by the sun's gravity. Their orbits are elliptical, closed loops around our star. An interstellar object, on the other hand, follows a hyperbolic path, an open curve. It enters from deep space, is deflected by the sun's gravity, and escapes forever. It will never return. That one detail, the eccentricity of the orbit, is the smoking gun. In astronomy, eccentricity measures how stretched an orbit is. Planets have values near zero, almost circular. Comets have higher numbers like 0.9. But anything over 1.0 means the object is on a hyperbolic escape trajectory. Before 2017, the only hyperbolic objects we knew of were comets kicked out of the solar system by planets like Jupiter. They were born here but got thrown out. An incoming hyperbolic object from outside? That was theory, until ʻOumuamua, the galactic pinball game. How do interstellar objects form? Planetary systems are chaotic in their youth. In the first few million years after a star forms, a disk of gas, dust, ice, and rock surrounds it. Small clumps collide and merge, growing into planets. But for every planet that forms, countless other fragments are left behind. Some of these fragments are unlucky. They get too close to a giant planet like Jupiter, which slingshots them away at escape velocity. This process is called gravitational scattering. It doesn't just happen here, it's universal. Every star with giant planets will fling material into interstellar space. Over billions of years, these fragments drift through the galaxy like cosmic refugees. Some may remain intact. Others are shattered by collisions. And a few will, purely by chance, pass close to another star, like ours. To put this in perspective, imagine 1 trillion tiny messengers, each carrying the history of a distant star system scattered across the Milky Way. And every so often, one of them knocks on our door. October 19th, 2017, the day astronomy changed. At the Pan-STARRS 1 Observatory in Hawaii, astronomers scan the night sky every night for moving objects, especially those that could threaten Earth. That night, astronomer Robert Warwick noticed something odd. It was faint, too faint to be a nearby asteroid, but moving fast. Its path didn't match anything in our catalogs. Over the next few days, more observations poured in. When scientists calculated its orbit, the result was shocking: eccentricity 1.2. This was the first confirmed interstellar object. It was named ʻOumuamua, meaning a messenger from afar arriving first in Hawaiian. And from the moment it was found, it refused to fit neatly into any category. ʻOumuamua was small, maybe 100 to 200 meters long, but unlike any asteroid or comet we'd seen. Its brightness changed dramatically as it rotated, suggesting it was either extremely elongated, like a cigar, or extremely flat, like a pancake. There was no visible coma, no dust tail. Yet as it left the sun, it accelerated slightly, as if something were pushing it. For a comet, that something would be gas jets from sublimating ice. But no jets were seen. This led to a storm of hypotheses. Maybe it was a fragment of frozen hydrogen or nitrogen, which would sublimate invisibly. Maybe it was a shard from a shattered exoplanet's icy crust. Or maybe it was artificial, a thin light sail drifting through space. The last idea, proposed by Harvard astronomer Avi Loeb, ignited a media firestorm. Most scientists were skeptical, pointing to natural explanations. But the truth was, there wasn't enough data to be certain. By the time we found ʻOumuamua, it was already speeding out of the solar system. We had only weeks to study it. It left behind only mysteries. Borisov, the familiar stranger. In August 2019, a very different kind of interstellar visitor appeared. Amateur astronomer Gennady Borisov spotted it using a telescope he had built himself. This object, later named 2I Borisov, was clearly a comet. It had a bright tail, a glowing coma, and spectra showing cyanide gas and water, just like comets in our solar system. It was bigger than ʻOumuamua, about 1 kilometer across. Borisov's chemistry suggested something fascinating. The building blocks of planetary systems are similar across the galaxy. While ʻOumuamua was a puzzle, Borisov was a confirmation. Interstellar comets are not just possible, they're real and perhaps common. How we spot the unspottable. Detecting an interstellar object is incredibly hard. They are small, dark, and move quickly across the sky. By the time they are close enough to be seen, they are already on their way out. Surveys like Pan-STARRS, the Catalina Sky Survey, and the upcoming Vera C. Rubin Observatory are our best tools. Rubin, set to begin operations soon, will scan the entire visible sky every few nights, spotting faint movers earlier than ever before. Early detection is the key, because if we spot one far enough away, we could send a spacecraft to meet it. Why they matter. Every interstellar object is a sample return mission we didn't have to launch. They are untouched fragments of other star systems frozen in time. Studying them could reveal how common water and organic molecules are in the galaxy, whether planetary building blocks are similar everywhere, if the seeds of life could travel between stars, the panspermia idea. They may even help us understand the conditions under which life itself can emerge. Theories, controversies, and the edge of science. ʻOumuamua in particular has fueled a spectrum of theories. Some are conservative, exotic ices, unusual comet activity. Others are bold, alien probes or debris from interstellar technology. While the alien idea is far from mainstream, it has served a purpose. It forces scientists to consider possibilities without prejudice, and to recognize that our observational window was too short to rule out much of anything. The future of interstellar exploration. Several missions are in development. ESA's Comet Interceptor, launched 2029, will wait in space, ready to intercept a future visitor. NASA's Project Lyra proposes chasing ʻOumuamua with high-speed propulsion. Starshot technology could one day send tiny probes to nearby stars, and perhaps meet interstellar objects along the way. With Rubin Observatory likely to discover dozens more in the next decade, We may soon have our first close-up images of alien comets and asteroids. Across the void, interstellar objects remind us that we live in a galaxy in motion. Solar systems are not isolated. They exchange material, share chemistry, and perhaps share the ingredients of life. Each time one passes through, it is as if a message has been delivered, from one corner of the galaxy to another. And while we may never know the full story of ʻOumuamua, we are entering an age when we won't just watch these messengers pass by. We will meet them. We will study them. And maybe, just maybe, they will tell us something about where we came from and where else life might exist. Thank you for watching. If you enjoyed this video, let me know your thoughts in the comments. I always enjoy hearing from you. Don't forget to like, share it with friends who enjoy fascinating topics, and subscribe so you never miss the next story.